This is a Chapter 5 review. Number 1, it says consider the leading term of each polynomial function. What is the end behavior of the graph? So our leading term is negative 3x cubed. When we have an odd function or an odd leading term, the exponent is an odd number. We'll get that right. Then one's going to go up and one's going to go down. And when it's negative, that the first coefficient is negative. That tells me that it's going to end going down. So this guy is going to look like this. And so it's going to go up and then down, which is C. Number 2, same thing. We look at that leading coefficient. You do want to make sure that they're in descending order. And you combine any like terms. This is an even function because it has an exponent that's even, which it means they're both going to, the end behavior is going to go either up and down and down. This is positive, so it's going to go up and up. If it were negative, the first coefficient, then it would be down and down. So this is C as well. Number 3 is very similar to 1 and 2, except we only have one term, so it's one leading coefficient. It's odd, so it's going to go, one's going to go up and one's going to go down, and since 1/4 is positive, it's going to end going up, so it's going to be down and up. And we actually have two possibilities for that. We have C and D are both possibilities. We just need to check which one by picking a point from each graph. So I've got 0, 3 here, and I would substitute it into the equation and see if it's a true statement. And I have 0, 0 for this one, and I would do the same thing. I would substitute it in the equation and see if it's a true statement. And I know it is, so that's going to be D. Okay, number 4, it says, what is a cubic polynomial function? So a cubic means that we're going to have degree of 3 for this function. And it also tells me that I'm going to have 3 solutions. It tells me that I have 3 zeros. Those are 3 real solutions. So I'm going to take those solutions, I'm going to write them as factors, and then I'm going to multiply them out to get my polynomial. So I've got x equals negative 4. I've got x equals 5, and I've got x equals 4. I'm going to bring them over with the x. So that gives me a factor of x plus 4, x minus 5, and x minus 4. And you can really multiply in any order that you want to get that polynomial. I think I'm going to be really sneaky here and do the x plus 4 and x minus 4 together because it's a product of a sum and a difference, and my middle terms will end up canceling. So I still have the x minus 5. X plus 4 times x minus 4 is x squared. My outer and inner terms will cancel for those, and I'll have minus 16, and then I'm going to FOIL there as well. So I'm going to try to do it so that it ends up in descending order. So I have x times x squared is x cubed, and I'm actually going to do the inner before the outer because the inner term is going to have the x squared, so minus 5x squared. The outer is minus 16x, and the last term would be plus 80, and that's going to look like one of these, and I should have a right answer. Sorry about that. I see what I did wrong. I don't have x equals 5. I have x equals negative 5, which is going to make this x plus 5. It's going to make that work out a little bit better. And this will be plus 5x squared. Sorry about that. And clearly I'm in a hurry. You can get a new teacher next week. All right, this is going to be minus 80. And so my answer is D. All right, number 5, classify negative 2x to the 4th, blah, 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 by degree. So we're always looking at that first term to find the degree. The degree is 4. And a polynomial to the fourth degree is a quartic polynomial. So quartic is my answer. Number 6, we're going to classify by the number of terms. As you can see, we have 1, 2, 3, 4. Anytime I have 4 or more terms, I just call it a polynomial. Number 7, we're going to write the function in standard form. So the first thing you want to do is distribute and get rid of the parentheses, and then you want to make sure it's in descending order. So when I distribute first, I'm going to get positive 10x to the fourth minus 8x to the fifth, and you can see that it's not in descending order. So I'm going to kind of flip that around and say minus or negative 8x to the fifth plus 10x to the fourth. Number 8, what is the relative maximum and minimum of the function? So for this one, I would graph it on Desmos, and then this is roughly what it's going to look like on Desmos, okay? And so I have a max here and a minimum on the bottom. My max has an ordered pair of negative 1.53 and 12.008. So that's my maximum. And this is my minimum. And it has an ordered pair of 1.2 and negative 8.304. So just put that on Desmos and you'll be able to see where the maximum and minimum are. Number 9, it says, what are the real solutions of the polynomial? Real solutions are solutions that cross the x-axis of the coordinate plane. And if there are any imaginary solutions, that's where they don't cross the x-axis. So for number 9, I would graph it on Desmos, and I would see that the graph crosses the x-axis at 2. So my real solution is 2, and then that's the only place it crosses the x-axis. So that's going to leave me with 2 imaginary solutions, and I know that because the degree of the polynomial is 3, and that tells me how many complex solutions I have, and that's going to be a combination of real and imaginary. So I've got one real, which is 2, and then I would have 2 imaginary solutions, so that makes my 3 solutions. And I'm going to do the same thing with number 10. I'm going to graph that, and I find that I have 6 as a real solution, and I also have 2 imaginary solutions. Desmos, Desmos, Desmos. It's your friend. Number 11, find the real solutions of the equation by graphing. So this time we're looking to see if only listing the ones that are the real solutions, so the ones where they cross the x-axis. And for number 11, this one is interesting because we have our graph, and then when we go to graph that, it's actually above the x-axis, and so it doesn't even cross the x-axis at all, which means there are no real solutions. Real solutions can only happen where it crosses the x-axis. Number 12, it says we're going to have 3 solutions. We actually have 3 real solutions. We have negative 1.87. We have 0 and 1.07, and those are all places where the equation crosses the x-axis. Okay, number 13, it's kind of a sneaky one. We've got our coordinate plane, and then when we go to graph it, here's what we see. We see it come down, and it's going to hit 3, and then it's going to go back up. Okay. Anytime it just touches the x-axis and then kind of bounces, goes the opposite direction and doesn't actually go through, that's going to show a multiplicity of 2. So we expect to have 2 solutions because the leading term has an exponent of 2. And it's because 3 shows up twice because it has a multiplicity of 2. So that's our solution. Just 3, and it has a multiplicity of 2. Okay, number 14, same thing. Where does it cross that x-axis? That's where our real solutions are. And we have 3 solutions, but we actually only have 2 real ones. All right, number 15, it's a little bit of a sneaky one. It says the dimensions in inches of a shipping box at we ship can be expressed as width, length, and height. Width is x, length is x plus 5, and the height is going to be represented by 3x minus 1. The volume is 7.6 feet cubed. We want to find the dimensions in inches. So remember that the volume is cubic feet. That's okay. We're going to leave it like that. We know that volume equals length times width times height for a box. And so that's going to give me 7.6 is equal to, and it doesn't matter what order we're going to put it. I'm going to put x times x plus 5 times 3x minus 1. You can actually put this in Desmos if you bring the 7.6 over with the rest of the function. You don't have to multiply anything out or anything. And so in Desmos, you're going to put y equals x times x plus 5 times 3x minus 1 minus 7.6. Okay. And see what they get for x. Remember that x is the length, and so you're going to get an x value, or excuse me, x is the width. So you're going to get a value for x. You're going to get a value for x plus 5, which is the length, because they want us to find the dimensions, and then 3x minus 1. I'm going to show a little bit of the work above here. So just to give me some extra room, I've got x equals 0.846 feet. Then x plus 5, I'm just going to add 5 to that, and I get 5.846 feet. And then 3x minus 1 is the height, so I'm going to put that 0.846 into that expression, and I get 1.538, maybe, feet. Now, it did ask for my dimensions to be in inches, so in order to convert those all to inches, from feet to inches, just multiply them by 12, and the result is going to be your dimensions in inches. Okay, for number 16, it does say to divide this polynomial by x plus 4. You just want to make sure that your polynomial is in descending order and that you're not missing any terms. And we do. I thought I'd do this one by long division just so you could see what that would look like. And we have 4x to the third plus 2x squared plus 3x plus 4. And we're going to divide that by x plus 4. I'm just going to look at my very first terms of my polynomial and my divisor to figure out what's going to go in my quotient. So I want to know, what would I multiply x by to get 4x cubed? And that's going to be 4x squared. And so I would have 4x cubed, then when I multiply through, plus 16x squared, because 4x squared times 4 is 16x squared. And then I'm going to subtract them, and I get negative 14x squared. Now I need 2 terms since my divisor has 2 terms, so I'm going to bring down the 3x. And then I'm ready to put another term in my quotient. I have to multiply x by negative 14x. And so the product would be negative 14x squared minus 56x. And I'm going to subtract again, so that's actually going to be 59x. And I need to bring down the 4. I need to add or multiply by 59 times x to get 59x. And then 59 times 4 is plus 236. Again, I'm going to subtract, and that's going to give me negative 232. So this is a big one. We get 4x squared minus 14x plus 59 with a remainder of negative 232. Number 17, we're going to divide using synthetic division. So synthetic division is a little bit different. We do need to make sure that our polynomial is in descending order and that we're not missing any terms, and we're just going to write down the coefficients. We're going to write negative 4, 21, negative 23, and 6. And then the x minus 4, we're going to set that equal to 0, and we find that x equals 4 when we do that. And that's what we're going to divide synthetically by. We're going to divide by that negative, or divide by 4, sorry. Okay, we always bring down that first term, so that's negative 4. And then you're going to multiply 4 times negative 4 and put it in the second column, which is negative 16. Alright, you're going to add that column, which is 5. 4 times 5 is 20, so you put it in the third column. Add again is negative 3. 4 times negative 3 is negative 12. And you add the last column is negative 6. That last column is where you're going to get your remainder. So the first three numbers, that's your quotient, and you're going to have one exponent less than you had in the originally polynomial. And you get negative 4x squared plus 5x minus 3 with a remainder of negative 6. Number 18, you would also divide by synthetic division. Again, you have to make sure, though, that you're in descending order, and that means that you're going to have to switch these two, okay, and fill in an x to the second. So you need negative 14x cubed plus 0x squared plus 14x minus 840. So now it's in descending order. You've got your term filled in, and you're ready to do synthetic division. Number 19 says use synthetic division to define p of negative 2. That just means what's the remainder when you're dividing by x plus 2. But the remainder theorem says we just have to put that negative 2 into the function, and that's going to be what our remainder is, and that's what we really want to know here. So I'm going to put p of negative 2 into the function, and I have negative 2 to the 4th plus 9 times negative 2 to the 3rd minus 9 times negative 2 plus 2. I'm going to work all that out, and I get negative 36. That just tells me that if I divide the given polynomial by x plus 2, that my remainder is going to be negative 36. Alright, number 20, it says how many real and or imaginary roots does the polynomial have? Roots are just solutions. So you can have some real ones, you can have some imaginary solutions. The real ones are the ones where it crosses the x-axis. So how many I have? I'm going to have 3 real and or imaginary roots in that polynomial because I have degree of 3. Number 21, find all the real roots of the equation. If there are any imaginary roots, how many are there? So for a problem like this, all I need you to do is to go into Desmos and graph the equation, and the real roots are where it crosses the x-axis. And so if I graph this guy on Desmos, I actually have 4 different places where it crosses the x-axis. So that means it has 4 real solutions and no imaginary ones. That's because I can tell from the degree that I should have 4 solutions. And it's plus or minus 2 and plus or minus 1.414. Number 22, again, I want to find all the zeros. So if I come across any imaginary solutions, like for number 22, I'm expecting to have 5, but my zeros are my real solutions. And if you graph it on Desmos, it only crosses the x-axis in 3 places, at -3, at 3, and 5. So I actually only had 3 real solutions, so 3 zeros, and my other 2 would be imaginary. But I don't have to list those because it's only asking about finding the zeros. The same thing for number 23. I expect to have 3 solutions, but I find that I only have 1 real one, which is at 1. So there's 1 real solution, and then there would be 2 imaginary solutions. You would do the same thing for 24 and 25. You want to take your equation and you want to graph it and find any zeros. And those are your real solutions, where it depends on the method that you use. If you bring everything over to one side, like for number 24, if you bring all the parts over, you can just see where it crosses the x-axis. If you make 2 separate equations, you want to see where those equations intersect. Honestly, I would probably say bring everything over to one side and then just see where it crosses the x-axis at. On number 26, you're going to make a linear equation. And so that's the equation for it, and I'm going to go into Desmos and I'm going to put in my table of values. Then my second step is going to be to enter the form of my linear equation. And the third step is to follow that line that I'm going to get until I get an x-coordinate of 1993. My corresponding y then is going to be the milk production for that year. '27, it's really going to be this very, very similar to that. Number 27, it wants you to give a cubic model and then find out what happened in 1997. So the same thing you're going to make, you're going to go into Desmos, you're going to add a table and put in your values, your data for that table, and then you're going to add a cubic function, and your cubic is going to look like this. Y sub 1 equals a x sub 1 cubed plus b x sub 1 squared plus cx sub 1 plus d. So that's what we're going to end up putting into Desmos. And then you're going to locate where the x-coordinate is 1978. And you want to find that corresponding y value. You can also substitute 1978 in for x. It's just going to take a little bit more work, but they'll both give you the same answer. Okay, for 28 and 29, it's a little bit complicated how we actually get the quartic function. There will be a similar problem like that on the test, but it will be a multiple choice. So you'll have the different functions, and what you would do is substitute those functions into Desmos, put those functions into Desmos, and see which one gives you a graph that only has 2 zeros of 3 and 5. And so that's what you would do for 28. And you do the same thing for 29. You'd put those equations in to Desmos, and then you'd look to see which ones have only 2 zeros there. Number 30, it says write a polynomial in factored form. Anytime you factor, so this one you're not going to do on Desmos, but anytime you factor, you want to take out a common monomial. We can see that we have an x in common for all 3 terms. And then I also want to look at the smallest coefficient, which is 6, and see if it will go into all 3 terms. And we find out that it will. So I'm going to factor out a 6 and an x. And so for the first term, that's going to leave me with an x squared. The second term will be minus 10x. And the third term will actually be plus 24. Now I'm not quite done yet. I factored out that monomial, but I need to see if I can continue to factor. And I have a quadratic that I can factor into 2 binomials. I still have that 6x, so we don't want to lose him. Factors of x squared will be x and x, and then I just need factors of 24 that when I add them together will give me negative 10, and that would be negative 6 and negative 4. So those are my factors of my polynomial. All right, thanks for watching the video. Hope it was a good time for me, good times, and good luck on the test. Happy studying.